Hello there everyone. This is a quick video in which we're going to talk about the features of a full isokinetic report, such as you will need to interpret for your summative assessment for this module. Now, this is a report that is available to you on Brightspace, but I just want to point out that I'm not giving any unfair or undue advantage to this person's report and anyone who chooses to interpret this data, because I've chosen this page because there's not really that much to talk about. As you can see by the deficit values here, most of them, with the exception of a couple here in knee extension and a couple in knee inflection, there isn't really a huge amount to talk about. So there are some talking points. There's enough for us to discuss to get something meaningful from for the purpose of this video, but I wouldn't talk about this particular page of this report in any great detail. But let's begin by orientating ourselves to the page. Now, first things first, you have this large table of results here at the top. In the first column, we have information such as the number of repetitions that were performed on each limb. Just highlight that there for you, on the left side and the right side. Now, naturally, we are almost always going to perform the same number of repetitions bilaterally, but it's just there if you need it. It's also here at the bottom on this line graph here. You are also given each of the measurements that can be derived from this data in this first column. Everything from peak torque here at the top, which, as I'm sure you know, is an important value for isokinetic report, down to the agonist-antagonist ratio here at the bottom, which again we're going to talk about in some detail. The line graph here at the bottom, torque in Newton meters up the y-axis, time in seconds along the x-axis, is not really something that you need to worry about for this report and for your assessment. This just gives you an idea of the average torque produced on the left and right limb during flexion extension. This green line gives you the position in degrees, which is measured up the secondary y-axis here on the right hand side. But this isn't something you're going to discuss, so all I'm trying to say is you can just overlook this particular portion of the report. So in the next sub-column, I suppose you could say, we have the various units of measure. So we have our measurements in the first column, and in the second column are units of measurement. So what each of these measurements are recorded in. So for example, peak torque we record in Newton meters. The agonist-antagonist ratio is, despite being a ratio, represented as a percentage, but we'll talk about that more in a moment. So along the top we then have a reference to what movement was being recorded. So in this case, this was extension and flexion, and as you know, this is knee flexion and knee extension. So the way to think of this is the knee extensors, i.e. the quadriceps femoris, and the knee flexors, which include the hamstrings and the gastrocnemius muscle. So again, just to point out that we cannot isolate with isokinetic dynamometry alone individual muscles within a muscle group. We need to incorporate surface EMG for this, which we will talk about at another point. But it's certainly something that you can raise, albeit briefly, in your summative assessment. Below this, we then have the angular velocity that the limb was tested at, in this case 300 degrees per second. That is the same for both movements, extension and flexion. However, we do have the capacity to have a variable angular velocity in a test. So if you're wondering, well, what's the point in reporting that twice, there is a reason. It is possible to do with the latest system on the Biodex. So below that then, if you take everything to, and I'm going to try and draw this as straight as I can, but I'm failing terribly, to the left of the line that I've just drawn, and to the right of the units of measurement here, then these three columns all relate to the extension movement that was performed. So you have the uninvolved and the involved limb. Now, as we've already discussed, involved and uninvolved can mean different things. So it could mean a previously injured limb could be the involved limb, and the uninvolved limb could be an uninjured limb. It could refer to the dominant limb or the non-dominant limb. And this is something you would need to make a note of during your testing. I can't recall for this particular test off the top of my head, but it will have a meaning that you will have had to have entered at the beginning of the test when you're setting up, or you put that there is no involved or uninvolved limb. The column next to this shows a deficit if one exists. Now, they don't give you a deficit for each measurement, but fear not, we will work out how that is done. But we do get the deficits for some measurements. I'll explain, as I say, on a separate page how we can work these out for ourselves. But it basically shows you the difference between the left and the right limb and reports it as a deficit value here, which is basically a percentage difference between the two. Remember that anything below 10% is considered normative. So you have a dominant and a non-dominant limb, you're going to have a slightly stronger and weaker side. So this value here for the peak torque that we've got of, we may as well just call that 4. If we're rounding down, it is perfectly acceptable and perfectly normal. Likewise, on the flexion side of things, a value of 7.4 is a bit higher, but still within normative ranges. Anything from 11 up to 25% is considered cause for intervention, and anything above 25 is a significant bilateral asymmetry that requires significant action to address. So to the right of this line here, we have the flexion movement, the opposing movement, and it's the same values. You have the involved and the uninvolved limb, or the uninvolved and the involved limb, left and right, and the deficit between the two. So that's just a quick orientation. In the next video, we're going to look at what these measurements mean and how to start to interpret this data.